In this section, we are going to discuss about machine learning. What is machine learning and how it works? Let's take a real life example of a child. A child starts to learn things by observing them over and over again. Similarly, machine learning is a computer program which has an ability to learn without explicit programming. That is by learning through data. Data for machine learning serves as observations. In other words, a machine learning is a program which can learn by patterns in the data, and it develops a mathematical equation. We call that as a model. Now, when a new data set comes, that means a data which the model has not seen before. Because of the learned equation, the mathematical equation, it is able to predict what would be the output. Let's take an example. In this example, you are seeing price and profit. With a very simple mathematics, you are able to evaluate profit as 0.25 of price, a quarter of price, which means the price is 4 times the profit. Now, if the price is 200, the profit would be 50. Very simple. And that's machine learning. You don't have to program the equation, but you tell the computer program the data set, and based on the patterns, a mathematical equation is generated. So this model, this cube is the model. Let's look at machine learning in detail in the next section. Thank you. In the previous section, we discussed about the definition of machine learning by taking an example. The example was price and profit. Profit equals 0.25 times of the price. Let's look at machine learning with more examples in detail. When you were writing a computer program before even thinking about machine learning, normally what you would do is input would be the price. You would write the operation, which is profit equals 0.25 times the price. The computer program is going to give you an output as the profit. So you would provide input as price, operation would be the mathematical equation, and the output would be the profit. In machine learning, it's a little bit different. You would provide the computer program input and observation, which is profit and price. You would provide the computer program enough examples of price and profit. And the computer program is going to develop the equation, which is the operation for you, known as the model. And that is the difference between a regular computer program and a machine learning program. One more time. For machine learning program, you would provide input and observations. That means input and output. The machine learning program is going to develop a model, which is the mathematical equation for you. Let's look at other examples of machine learning. You have input as speech or voice, and observation would be command recognition. Think about Alexa, Google Voice, Siri. Input as emails, observations would be spam or not. You provide machine learning historical sales data and observations as sales forecast, input and output, and so on and so forth. Voice as inputs, observation as command recognition. You are generating an application known as virtual assistant. That is your Alexa, Siri, and Google Voice. If you provide labeled set of data like emails and telling the computer program, this email is a spam and this email is not a spam, it's going to automatically develop an application or a model for spam filtering. Similarly, if you provide historical sales data and the historical sales forecast data, it's going to help you to create an application for predicting the sales forecast for the future. There are a lot of applications for machine learning. All it needs is input and observation. And all these examples are artificial narrow intelligence, which means that the program which you're able to create is for a specific use case. And the use cases could be virtual assistant, spam filtering, predictive analytics, online ads, and so on and so forth. We have seen the difference between machine learning and data science. They're not the same. Now let's look at other components of artificial intelligence and how everything fits together. We will do this by using a Venn diagram. For the Venn diagram, the artificial intelligence forms the bigger bucket. The core of artificial intelligence is machine learning. Machine learning, as we have seen earlier, is mathematical computations of simpler problem as compared to the deep learning nets. Deep learning is a form of machine learning used for solving complex problems like image recognition, visual recognition, video intelligence, and other complex problems. Data science, as you have seen earlier, is not same as machine learning. It forms its own area. Data science is focused on why of a business problem versus machine learning, which focuses on what of a business problem. Next, there are few components like supervised learning, unsupervised learning, and reinforcement learning, which we are going to discuss in the next few slides. There are GANs, which is general advisory networks, which are core of deep learning. They are type of a deep learning problem. Next, we talk about chatbots, which are very common these days. RPAs, robotic process automation, virtual assistants like Siri or Google and other assistants, Alexa, and robotics. They're all forming an artificial intelligence family. Now let's talk about frameworks, the technology frameworks which enable artificial intelligence, machine learning, and deep learning. They are frameworks like TensorFlow, which is the Google open source framework for machine learning and deep neural nets. Keras, MXNet, CNTK, Caffe, PyTorch, Scikit-learn, R, and Weka are some other frameworks. Now let's look at some of the use cases of machine learning. Number one, weather prediction. Machine learning is being used to predict weather for the next few days based on various parameters like temperature, pressure, and the wind conditions. You're able to predict temperature. Click-through rate. It's a rate which tells you the probability of a user clicking your ad placed on Google, Facebook, YouTube, or any other website based on various demographic conditions. Sales forecasting. Predicting what products and how many products are going to be sold in the next quarter or year. And then price predictions. When you are launching a new product, you would look at similar products in the same category, brand or band, and find out what price would make more sense for attracting customers. All these, please note that are predicting some kind of numbers. So that means it's predicting something, that something is the target variable. And they're predicting numeric, also known as continuous variables. So here, the target is a continuous variable, and therefore the class of these use cases is regression. Now let's look at some other use cases. Customer churn or retention. That means what is the probability that a customer is going to continue doing business with you, or you will get a new customer. It's a classification. Diagnostic. Given an X-ray, what are the chances that a person has a particular disease? And image classification. Given an image of a cat and dog, to be able to identify whether it's a cat or a dog. Please note that you're predicting, again, the something here, which is the target variable, but you're predicting a class. Customer churn, yes or no. Diagnostic or image classification. All are classifications. There could be one or multiple classes. So the regression and the classification are part of supervised learning. A supervised learning is defined as a learning which has a target variable. That means you both have input and the output labeled data. Recall that earlier we discussed A machine learning is a program which can create a model for you based on input and observations. Now let's look at another leg of the machine learning, which is unsupervised learning. Unlike supervised learning, unsupervised learning does not have a target to predict. It just works on interpreting the data based on input data only. Again, it has two classifications, subclasses, clustering and association analysis. Let's look at some of the use cases of clustering. Recommender systems and target marketing are clusterings. You're forming clusters based on the spend, based on a lot of other variables. Association analysis is like customer segmentation. You segment customers based on some parameters. And market basket analysis. What is the probability that you're going to buy two products together? For example, when you go to the grocery store to buy milk, most likely you're going to buy bread and egg together with milk. That is an example of a market basket analysis. So I hope this is clear. Just to recap, machine learning has two broad categories, supervised learning and unsupervised learning. Supervised learning has target variable, where unsupervised learning does not have a target variable. The subclasses of supervised and unsupervised learning are regression, classification, clustering, and association analysis. And there are use cases associated with each of them. In the next few sessions, we're going to focus on supervised learning, and we will predict and write algorithms for regression, linear regression. Let's look at a real-life example of area and price. Please note that this area and price is test data set. Observing this data set, you would figure out that the price is linearly proportional to area. That means when the value of area increases, value of price also increases in a linearly proportional manner. That also means from our machine learning logic, area is the feature. That means area is the predictor which can predict the value of the price because they're linearly proportional. Let's plot all the values of area and price on a chart. Here is the plotted value shown with the blue dots. Drawing a line which encompasses all the values, you would see that all the values fall on the line itself. Please note that this is happening because it's a test data. It's a perfect linear regression data. Generally, this would not happen. You would see a lot of points above or below the line. Next, let's find out what would be the price of a house with area 1025, 1025 square feet. Interesting. If you see on the chart, you do not have the value for 1025 square feet. How are you going to calculate it? The method to do that would be to calculate the value of the slope of this line. I repeat, we need to calculate the slope of this line, and the equation of slope is y equals mx plus c, where m is the coefficient and c is the intercept. Let's apply this slope to our example of area and price. Price equals m multiplied area plus c. In the next few sections, we are going to input both area and price to a machine learning program and let machine learning figure out the slope without you have to explicitly write the equation. I repeat it one more time. In the next few sessions, in order to predict the value of 1025 square feet home, we will input all the inputs and observations. Remember, inputs and observations to a machine learning program, and let machine learning program figure out the equation, which is the model. And then we are going to predict the price of 1025 square feet home. The word predict is very important here. We do not have the actual value of a price of 1025 square feet home, but based on the machine learning model, you would be able to predict it. So input is going to be area, output is going to be the price, and the machine learning model is going to write the equation for you. And that would be a target which we will try to achieve. In the previous video, we looked at a data set, area and price, and that was our test data set. We will now use that data set to create a machine learning program in order to find an area 1025, what would be the price? Let's develop a flowchart for you to understand what would be the next steps. Number one, start, get the data. You would get the data in a CSV, which is comma separated file with two columns, area and price. Next, you would split the data. Splitting the data is important because you would have one data set, which is almost 80% of the data. You would keep it for training data set. That means using this data set, the model is going to train itself. Next, you will have test data set, which is going to be utilized for testing the model, if the model is good or not. Next, in the flowchart, using the data set, you would figure out if there is a target variable or not. In case you do not have a target variable, that means it's unsupervised learning. We have seen this in the sessions earlier. Next, we will figure out if our target is continuous or discrete. A continuous target refers to the column which can take any number, any continuous number. Versus discrete refers to a target where it can only take specified number of classes. Here we are doing regression. That means our target is price, which is a continuous. It can take any number. It takes any number, that means it's continuous, and that will be considered for regression model. In this case, the no is not going to be coming into picture. Next, we will train our model using a machine learning algorithm, which we are going to see in the next few sections. Once the model is trained, you would test the model. For testing the model also, there are multiple methods to validate and evaluate a model. We will keep it very simple. If the target is continuous, which is price in our case, we will use something known as RMSE, which is root mean square error. Where the targets are not continuous, that means discrete, you would use confusion matrix. Confusion matrix is out of scope of this syllabus. However, we will look at RMSE, which is root mean square error. You would ideally like root mean square error to be as low as possible, because obviously magnitude of error, you would keep it to a minimum. And once you have RMSE, which you are okay with, you would end the program. That means save the model. So that's how, these are the steps you would take. I repeat one more time quickly. Get the data, split the data into training and test. 80% and 20%, it's not mandatory. You can split it into 75-25, 70-30, but 80-20 is by default. Next, you would figure out if there is a target in your data set. In our data set, yes, the target was the price. Next, you will figure out if the target is continuous or discrete. In our case, it was continuous, so we will use regression. We will train the model, test the model using the test data set, which was your 20% which you had put aside. And I'm going to show you all of this in a Python program in a next few sessions. Next, if it is discrete or continuous, you would then evaluate the model using RMSE for continuous variables and confusion matrix for discrete variables. And then you would end the program. This is the flowchart which you would use in the next few sections to build your first machine learning program. Are you excited? I am. Keep watching. Hello. In this section, we are going to discuss about different programming languages for machine learning. We are going to discuss the top three, which are R, Python, and Java. R is an open source free programming package for statistical computing and graphics. Just like Python or any other machine learning languages, it has module and functionality which can cover a lot of algorithms on machine learning. Python, it's one of the most important and widely used machine learning programming language. It's also sometimes considered as the unofficial language for machine learning programmers. As we are discussing about Python, let's discuss about notebooks as well. Python notebook documents, or just simply notebooks, are documents which contain codes as well as comments together. When you create a machine learning program, you would practice something known as experiments. Experiments are basically considered those programs which are written on a data set to learn from the data sets, basically writing a machine learning program. Notebooks are widely considered to be the developer's module and integrated development environment to write your machine learning code. We are going to focus on Python in this course to understand and develop your first machine learning program. For the notebooks, we are going to use Google Colab for writing your code. You would see those in the next few sections. And Java, many developers prefer Java as their prime machine learning programming language just because Java has been around for the longest period of time as one of the most importantly and widely used coding language for enterprise applications. Just because Java has been around for so long time, many people prefer Java with so many functionalities for machine learning. If you are a Java developer and you know Java, I would recommend you to write machine learning programs in Java. Python, for this course, for new beginners, I would recommend Python because this course is totally oriented towards Python. As I said, please note that these are the top 3 languages. However, there are many other languages which can be used for machine learning programming development. So let's see in the next few sections how Python can be used for writing your first machine learning program. In this section, we're going to look at the Python libraries or packages which we'll be using. First one would be this. It's a very commonly used Python library which can help you to do analysis and manipulation of the dataset. Number 2, matplotlib. As the name suggests, it's a pandas matplotlib. As the name suggests, it's a Python library which is used extensively for plotting. Next is NumPy. Next is NumPy. It's another Python library which is very heavily used for mathematical functions and operations. And finally, we will use scikit-learn, also known as sklearn. It's a package which provides an extensive machine learning libraries like regression, classification, and a lot others. So let's dive into coding and let's learn machine learning. Let's look at some basic building blocks of Python language which will help you to build your first machine learning program. The import statement. We have discussed libraries in the previous sections like pandas, numpy, matplotlib, and scikit-learn. The import statement is used to bind those libraries, call those modules so that you can use them in your program. So in Python, modules are accessed using the import statement. The import statement is the most commonly used way of invoking the import machinery for accessing various libraries and packages. And when you execute the code, which can help module to be called in the scope of the definitions in your current program and use it. So this is how you would write an import statement. So the first line says import pandas as PD. That means we are importing the module pandas and referring it as an alias PD. Now PD as an alias, you can use it for the next set of statements rather than having to write the entire word pandas. It's optional. Similarly, we are calling another function in matplotlib known as pyplot. So matplotlib.pyplot as plt, and then sklearn has lot many packages, functions known as linear model, classifications, random forest trees, decision trees, and lot many. You don't want to call all those libraries in at one shot. Therefore, I would select sklearn.linear regression, linear model as linear regression. Using the test train split, which is model selection, remember that wherein you would use test and train split for your model building and testing purposes. This is the function which can help you do that. We'll use these functions in the next set of videos. The print statement. As in any other language, the print statement is like an echo. Whatever you write in the double quotes, it will be printed onto the output console. Pandas data frame. This is your next set, wherein you have pandas, as we discussed earlier, is one of the most widely used Python libraries in data science. It provides high performance and easy to use structures and data analysis tool. One of the most important things on Python that it gives you data frames, which are two-dimensional table objects. Think of any tabular model and it is arranged in rows and columns fashion. So data frame are two-dimensional structures which are aligned in tabular fashion in rows and columns. This is how you would write a data frame. First data frame equals pd.dataframe, and in round braces and the curly braces, you would write the name of the column like city ID and the IDs. First underscore df would print the data frame, and you would see one column city ID with an index starting from 0. Let's write a data frame with multiple columns. You would do this by writing city ID, city name, city, and temperature in this fashion. What you would need to do is, when we go to the Handson, test these out for your comfort. Next is in Pandas data frame to read a CSV file. Remember the area and the price? So the area and the price is available in regression-area price.csv, and you would use this command df equals pd, that is pandas dot read underscore csv, and the file name. In the next few videos, we are going to discuss about how you can save this file in a Google Drive and then access it for your programming language. The print command here is going to print the data frame. The data frame consists of area and price with an index starting from 0. The CSV file in a data frame using pd.read underscore CSV. And then you would define X and Y variable. X would be area and Y would be the price. In order to define that, you would use df, which is the variable data frame, and in square braces, you would use df as the data frame, and then use the square braces for area and the price. Please note that X and Y are the variables defined. Very interesting point. Why is X in caps and Y in lower cases? Think about it. Next, plotting the data. We are going to be using the matplotlib library. Please recall that we used the import statement. We used matplotlib.pyplot as plt. plt is an alias which I'm going to use now for plotting area and price in the scatter diagram. So plt.scatter x comma y, caps X, lowercase y, color equals blue. Now you are plotting this data. It's not mandatory to plot the data, but just for our visuals, it's important that you plot it. It provides you an understanding of how the data is laid out. So to answer the question why X is in upper caps and Y in lower caps, because X can be multiple features, but there can be only one target. So that is why we have mentioned Y as a lowercase and X as an uppercase, because X represents multiple columns. So this is just a simple example where X is representing area, but going forward, many features can impact a target, and therefore X is in uppercase. That was a mind twister, wasn't it? Let's follow the next set of videos. In this section, we are going to create a machine learning program using Python. For that, we will need a development environment, and that is Google Colab. Google Colab is a free service which is provided by Google, available on cloud. It's a totally free service. You can write Python programs on it. It not only supports Python program, but also supports Java, Linux, and other kinds of scripting languages. It provides ability for you to code machine learning using CPUs, which is central processing unit, GPUs, which is graphics processing unit, and TPUs, which is tensor processing unit. That too for free. You would not need any high performing computer for machine learning programs. You can use Google Colab and start creating your own machine learning programs. And this is what we are going to see in this section. You can develop deep learning applications also using popular libraries like Keras, TensorFlow, PyTorch, and OpenCV. In order to access Google Colab, you would need to visit https://collab.research.google.com. And if you need more details, visit this link in order to get yourself familiarized with Google Colab. Let's do a hands-on. Google and search for Google Colab. As soon as you search for Google Colab, the first link would say collab.research.google.com. Click on this. If this is your first time, it will ask for accepting few terms and conditions which you would normally do. I have written a lot of programs already, so it's not asking for me. Here at the bottom, you would see new notebook. Notebooks are development environments for creating machine learning programs. Notebooks are environments to create or write your code. This is a notebook available on cloud on collab.research.google.com. Just to give you a very quick overview of Google Colab, you would use this area to write any piece of code. So you can write import pandas is a library as PD. To get details on pandas, at the end of the video, I'm going to give you a link and you can watch those videos before you can do this hands-on exercise. So import pandas as PD. If you have to execute this command, just click on this link, this button. And you see that it's initializing an environment and pandas have been imported. Click on new code, this cell, and it says print I am here, and just run it. You need to know a little bit of Python, and for basics of Python, I'm going to give you a YouTube link as part of the description section of this video, and you can click on that link before you can do any exercises, any hands-on. So two things. Number one, what are pandas and how to import pandas? You need to know a little bit of programming, and that is going to be your next hands-on lab. So you don't have to just write one command at a time. You can write multiple commands as well. So this is like a hello world. And if you have to run this, run it here. Using this text, you can write some comments. So if I click on text, I can write This is my first program. These are comments. Without these comments won't be executed. Next, click on this header and say my first file, my first Python file. Please note that the extension is IPYNB, which means Python notebooks. It's a Jupyter notebook. People who are aware of Jupyter, which is a notebook environment, also known as IPython. If you're not familiar with any of these, just ignore and imagine that this is your development environment to write machine learning programs. I would like you to explore the file menu. You can make a copy, new notebook, or download this file as a Python executable program. Edit. You can select cells, delete cells, and do other edit. But one thing which is very interesting is in the runtime. If you click on runtime and change runtime type, you can select either none, GPU, or TPU. None will give you general CPU, regular CPUs. GPU is graphics processing unit, and TPU is tensor processing unit. That means it's specifically designed to run TensorFlow. All these are out of scope for this course. Now I'm just going to select none and save. Now let's look at the data file which we'll be using. So in your course content, there is a file known as regression-area price. Please download the regression-area price.csv file from the class documents. Create in your Google Drive, create a folder called ml-class and copy this CSV file in your Google Drive. Next, I'm going to show you on the left-hand side, there are 3 icons. Here at the last one, click on Files, and there is a Mount Drive. Mounting this drive, meaning you are mounting your Google Drive as part of this Python notebook. Connect to Google Drive, and you would see after refreshing that you have Drive, My Drive, and ML class. You would see this file. Right click here and say copy path. I want to get the path of this file. Click on new code and say pd.read_csv and just paste it. Because you have copied the path, just paste it. Put a single quote around the path and just run it. You would see that the data has been read. Let's look at the Handson. So steps for Handson: access the Google Colab using collab.research.google.com. You can register for free using your Gmail ID. Log on to Google Colab. Get yourself familiar with the following. Create and save a notebook. Selecting runtime options as shown earlier. You can select none if you are not writing very intrinsic machine learning programs. But if you're writing complex machine learning, you can choose GPUs or TPUs depending upon what your complexity level is. Copy the file which I just showed you into your Google Drive. The file name is regression-area price.csv. Access this file in Google Colab using Pandas library as I showed earlier. And optional, if you want to learn basics of Python computer program, you can watch this video. Complete the hands-on. In this section, we are going to discuss about linear regression. Please recall our machine learning flowchart. We got the data, then you have to split it in training and test data set. Let's do the splitting. Next, we know we have a target. We know our target variable is continuous. We are going to write a regression. In our example of area and price, we are going to write a linear regression example. And then we are going to train a model. Let's use linear regression from scikit-learn package. So what is linear regression? As the name suggests, the term linearly refers to a relationship between two or more variables which are correlated in a linear fashion. In our example earlier, area and price were plotted which form a straight line. Linear regression performs a task of predicting the value of price given an area. The linear regression technique would be used to find the correlation between the two variables, area and price. Let's see how. So, splitting the data set would result into 4 variables: the X train, Y train, X test, and Y test. These are the 4 variables would come out of a result of splitting the data, that is X and Y, split into 4 different variables: X train, that means area for training, price for training, area for testing, and price for testing. We will use these variables in our code. How to write a linear regression? You would use linear regression. Remember, linear regression was an alias, remember the linear regression was an alias for scikit-learn .linear_model using our import statement earlier. We are assigning it to a variable LR. LR.fit, you will pass X train and Y train variables. This is for training. For training purposes, we'll use LR.fit. And for predicting or evaluating purposes, we are going to use LR.predict, X_test. Recall that we are on our mission to find out what would be the price of the house if the area is 1025 square feet, given the data set what we had earlier. So in this case, this is only for testing purposes, wherein you would calculate Y_pred. That means the predicted value when X_test has been passed through the model. In order to check the accuracy of the model, you would compare Y_pred, which is what the model is predicting given the test values of X, versus the actual test value of X, which is Y_test. So think about this. You have split the data set in X train, Y train, and X test, Y test. You used X test and Y test for testing purposes. The model was created based on the trained data set. That means LR.fit X train, Y train. Now the model, which is LR, has been trained. How do you test it? You test it by passing the value X_test. The values of X you kept aside for testing purposes, and find out what the model suggests the value of Y_pred would be. Then you compare the accuracy of model by looking at the predicted value of the models versus what were the value of Y_test. We will see that as code in our next few sections. Let's look at how would you write this in Python. So for splitting the data into 2 parts, train and test, this is based on our machine learning flowchart, X train, Y train, X test, Y test. You would use this. You would use the train test split function from, again, scikit-learn model selection. Please remember, look at the import statement earlier. This is what we imported. X, Y, random state equals 0. For now, Do not worry about random state at all. Random state definition is out of scope of this syllabus. Next, let's see how would you write linear regression. For linear regression, as we discussed earlier, you have to have linear regression assigned to a variable LR, use LR.fit, pass in the train values x underscore train and y underscore train. For predictions, use y underscore predict equals LR.predict, pass on the test values. Let's see. So LR, you are defining linear regression. Please note that this print statement is just for echoing purpose, just for output console. Here you would write LR.fit x underscore train dot values dot reshape. Because area is a single dimensional input, you would use this. This is just a coding methodology. For now, do not worry about it. Assuming that this whole forms your X train, focus on that. And then Y underscore train as is. I repeat it one more time. LR equals linear regression. LR.fit is for training purposes, passing on X underscore train and Y underscore train. For now, just write dot values dot reshape -1 to 1. This is just for shaping purposes of the data frame. For now, just ignore. Next is predicting. For predicting, you would use LR.predict x underscore test dot values dot reshape as you had done for train as well. And then Y predict would be your predicted values. In order to calculate RMSE, you would use or you would compare YPred with Y test. Let's see that in the next section. Root mean square error, RMSE, is a KPI, a key performance indicator to evaluate the accuracy of a model. Let's see that in the next section. Hello. In this section, we are going to talk about the model evaluation of the linear regression algorithm, which we have written in the previous section. How good or bad a model is given your data set. Is it a good fit or not? That is the criteria of evaluation. To evaluate scientifically, there are two KPIs, meaning key performance indicators. The first one is RMSE, which is root mean square error. It is the square root of the mean square error. What it means is the difference between the actual value of y, which is y underscore test, and the predicted value of the y by the model, which is y underscore pred. The difference between these two values define the error, and the square root of those is the root mean square error. Another KPI, which is R squared. R squared is a statistical measure of how close the data is to the fitted regression line. Remember the points we plotted and the line which we have drawn earlier? In the real-time world, you would definitely not get a perfect linear regression problem. Please recall that our data set was a perfect data set for linear regression. That means it formed a perfect line which can encompass all the plotted points in our previous section, right? So in the real-time world, you would like the value of R squared to be as close as possible to 1, while you would like your error, which is the root mean square error, close to 0. It does not happen normally, but you would try to get it there. So from a Python code perspective, this is how you would write. Here you have sklearn.metrics. You would import a function from the scikit-learn mean squared error and the R2 square. From these functions, you would calculate RMSE and R2 by passing in y underscore test, which is the actual value of y, and y underscore pred, which is the predicted value of y in both of these functions. Because remember, our data is a perfect linear example, the root mean square error is 3.62 e raised to minus 21, which is 0.21 times 0 and then 20 times 0 and then 362, which is almost 0. And then r square score is 1.0. And as discussed earlier, our data set was a perfect linear regression data example. And therefore, my RMS is tending to 0 while R2 square is tending to 1. It does not happen in the real-time world, but this is you would like to achieve. Call a regression example. In our regression example, all the plotted points form a straight line. That means all the points fall on the line, and therefore R square is 1 and there is no error, which is RMSE was 0. Let's find out the price for a house where area is 1025 square feet. That means let's find out the price for a home with area 1025 square feet. This was our target. So remember, the slope of a line is y equals mx plus c. This is what we discussed earlier. That means the price is m times area, x is our area and y is the price, the plus c. So the two properties of linear regressions are intercepts and coefficients. Of the line for linear regression is y equals mx plus c. Now, there are two properties. M is the coefficient and C is the intercept. Let's use the properties to write a mathematical equation in the form y equals mx plus c. Please note that you haven't written the equation. However, the machine learning model algorithm was able to derive that equation for you. This is a concept of machine learning where you input both the input data and the observation, and machine learning does the operation for you. Please note that in none of the programming sections you have written explicitly this equation, and this equation you would see it will be derived by the Python program using the properties LR, which is linear regression dot intercept, and LR dot coefficient. You would see the equation here. 199.5 x plus 1574 is the constant c. That is your equation. You have not written the equation. The model was able to find out the correlation between y and x without you having to explicitly program for it. And that is, in essence, the machine learning fundamentals. Let's look at what would be the price for area equals 1025 square feet. So m is the coefficient and c is the intercept. Here, there are two ways you can predict the price of this home. First one is using the equation. You take that equation, which you just came to know about based on the properties shown. You would write this equation and find it for yourself, or use the machine learning learned model, which is lr.predict. Please note that in the previous section, we discussed about lr.predict. In the lr.predict, you would input the area 1025 and see the price. Please note that the price is unknown. We do not know yet. Let's look at it. So this would be y underscore price underscore 1025 is my variable for the price, and then lr.predict. Please note a double square because that is how the data frames work, 1025. So the predicted price of 1025 square feet area is this variable y underscore price underscore 1025. The price of 1025 square feet area home would be $206,061.50. That's how you are able to predict using machine learning. And this is nothing but a mathematical equation. This section is about hands-on labs. What you have learned earlier on regression model and machine learning models, you would practice over here. Let's see how would you do the machine learning model on Google Colabs by yourself? Number one is access getting started linear regression hyphen prediction IPYNB, which is the Python notebook. Make a copy of the notebook. I'm going to show you in a few minutes how to make a copy of this notebook. From the file menu, click on save a copy in the drive, and finally execute the steps in the notebook. All of these steps are exactly the same steps what you have done in the previous sections. See how it works. So this is the notebook. You go here, go to file, and save a copy in the drive. Once you have the copy, you would scroll through it and start running this notebook. At the end, you would see all the steps what you have performed till now. It's the price of the area 1025 square feet. I hope this course was helpful to you.